The lesson today, though, is scientific notation. How many people have done this before? Oh, great. This should be a review then. All right. Let's roll through. Standard form to scientific notation. Here is a step-by-step process. Now, the words to it can be somewhat confusing if you just know how to do it. Take notes at your own leisure or whatever. Step 1. Move the decimal point until it is to the right of the first non-zero digit. The result is a real number, and we're going to label that A. Okay, a real number A. Step 2, take note of the number of places N and the direction that you move the decimal point. Okay, so whether you moved it to the left or to the right, and how many times you actually physically moved the decimal point. Step 3, if the decimal point is moved to the left. Okay, now let's think about this logically. If we take a number, if we have a number and we move the decimal point to the left, what are we doing to that number?
Making it a fraction.
You're making it smaller. Okay? You're making it smaller, right? If you're moving the decimal point from here to the left, 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 until I get to my coffee cup, assume my coffee cup is 1, you're making it smaller, right? Okay? Assume my coffee cup is 1 again. If I move my decimal point to the right, 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 I'm making that number bigger. Okay? But remember what my original number is. It's back here. Okay? That's why it's kind of backwards. Okay? So if you move your decimal point to the left, you're making your original number smaller than what it actually is. So the exponent needs to be positive. That way, whenever we talk about that number, we're saying, hey, it looks small, but actually it's big. Vice versa, if you move your decimal point to the right, did I do that right? No, I did that backwards. To you guys, anyways. You move it to the right, typically you're making your number bigger. Therefore, you need to make your exponent negative, so it represents you being smaller. It's kind of backwards. Okay? Step 4, easiest one. Remove unnecessary zeros. Okay? Have you guys done this here yet in science class? Or are you all in biology? Biology. Yeah, this is more a chemistry thing. So, I always debate whether to do it or not. I figure, what can it hurt? So, we're gonna do it real quick. All right? Shouldn't take too long today. Like I said, we'll do that other thing in a little bit too. Okay? All right. So, what you want to do, for those of you that, like I said, don't know, your decimal point is here at the end. All right, and then you want to move it from here, wherever it is, to the left. Okay, 1, 2, 3, 4. 6 times, or how many?
Negative.
No. How many more? What's that number need to be between? You need to move it 2 more. You need to move it 8 times total. Okay? Because remember, your whole number needs to be between 1 and 9.
Okay.
All right? So right now, you rewrote this 201 million as 2.01. Okay? And remember, since units, they're based on tens, right?
Yeah.
Okay, so we're going to rewrite this, or put this as times 10. And since you moved it to the left 8, backwards. Move your decimal right, you make a positive 8. Because remember, you're talking about a bigger, come on, write an 8. There you go. You're talking about this 2.01 times 10 representing a big number. Okay? So if this is going to represent a big number, then this exponent needs to be big. All right, make sense? Okay, we'll move it to the left, your exponent's positive. Over here now, move this one, 1, 2, 3, 4, 5 to the right, which gives you 5.1 times 10 to the negative 5th power. Okay, since you moved it to the right, your exponent's negative. Okay, that 5.1 represents your smaller number. Okay, 0.000051. Anthony. That's how, like, okay, so you know how you have tens digit, hundreds units, thousands digit, and they each move up by 10? Okay, that's why you do by times 10. Okay, decimal numbers. Alrighty. So as long as you make the number that you're talking about over here be between 1 and 9, alright, times 10 to the whatever power you however many times you move your decimal place. Okay, so the third one here, I kind of take jumps too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I don't, you don't need to write it out, especially if it's written with commas. Okay, because they put a comma every third. All right, so if they put a comma every third, I don't need to count it out every single time. So this becomes 6.87 times 10 to the 10th. And the other one, move it 1, 2, 3, 4, 5 again, so 7.25 times 10 to the negative fifth. Okay. All right, your science teachers love scientific notation. Okay. You can talk about big numbers, you can talk about little numbers, and quite honestly, that's where it's useful. As a math teacher, I have to struggle with this because what up there is making my blood boil right now.
The negative and positive.
No. The negative exponents. The negative exponents are making my blood boil as we speak. Okay? But the difference between this and what we have been doing is these are representing actual numbers. Okay? These are representing actual numbers that you're actually talking about. So these are okay to have as negative exponents. It's a little weird, struggle for me, okay, but they're okay. You can do that. All right, any questions? That's how you moved it. Refresh for everybody that didn't know, or teaching for everybody that didn't know, refresh for everybody that did. Everybody good?
Yes, sir.
Okay. Real quick, going the other way then. That's your steps for that. It's basically the same. You just go with it in reverse. If a times 10 to the nth power, know whether n is bigger or less than 0. If n is bigger than 0, you're going to move to the right. If n is negative, you're going to move it to the left. Okay? So if you're positive, you're going to move to the right, so that way you make your number bigger. If you're negative, you're going to move to the left to make your number smaller. Okay, make sense? Put in zeros where you need be. Alright, so 6.32 times 10 to the 9th. So which means it's positive, so we're going to move to the right, make it bigger. So here's what I do. 1, 2, okay? So 632, I know that. Okay, I moved twice, which gets me down to what number?
7.
7, so how many zeros do I need to add in?
7.
7, and then I just count the 7. 1, 2, 3, 4, 5, 6, 7, comma, comma, comma. What, 6,320,000,000 total? Okay. So 4 times 10 to the negative 7 is going the other way. Where does the decimal place go there? Okay, it goes after the 4, right? Okay, and this is the one where a lot of people mess up because they always go just 1, right? You have to move it to the left once. So how many zeros do I add ahead of the 4 then?
6.
6, okay? A lot of times I'll see 7. And yes, I actually go through and count these. Okay, but you need 6 zeros. 1, 2, 3, 4, 5, 6 zeros, and then your 4. Okay, same logic kind of deal. That's honestly that's how I do it whenever I do it myself. Okay, so 6, 5, 4, 3. So I need to add how many zeros at the end? 3. going the other way once. So I need to add in 4 zeros. So 0, 0, 0, 0, 9, 0, 3. Okay, so now what we're going to finish the day with is we're going to multiply these numbers together. No, by hand. I know. Okay, now, you can do this basically one of two ways, but since we're talking about scientific notation, chances are I want to see an answer in scientific notation. Okay,
This is a real world problem, right? Right. I feel this is like a problem, like a work problem.
Don't have one. Where's yours?
Here you go.
Thank you.
I want to see your answer in scientific notation. Okay? So, you basically have one of two options. You can use your calculator, you can get it into scientific notation that way. Okay? Just do the operations, make sure you have it set up right. But, chances are, I'm not trying to be mean, I don't think you guys are good enough with these yet that you're going to have it in right. Okay? I don't. I'm sorry. Maybe one day. I don't know if that day's today or not. Maybe it is. Maybe it's not. I don't know. So here's what I'm going to tell you to do. We want to multiply 3.5 times 7. Okay? Which gives us, what? 24.5? Okay? I did that. So what do you think I'm going to do next? Do the tens. Okay? Now, answer me this. Why is the scientific notation in this chapter? Why is this question here? Why is this question here?
It's power, like a negative power.
10 to the negative third times 10 to the what? Fifth, which becomes what? No. Isaiah. 10 to the second. Why 10 to the second?
Oh, that's the exponent.
Because you add the exponent because you have the same base. Oh, familiar? Very much so. Okay, this becomes times 10 to the second. Okay. All right, now, that's how you do the operation. Now, what's our one issue yet? No, there's no equal sign.
Oh, we have 24.
You have 24.5, and that's not what?
Single-digit number.
That's not a single-digit number, or singles. That's not between 0 and 9, or 1 and 9.
Move the decimal.
Okay, so now you got to move the decimal. Okay, which will happen. Okay, which is why this book makes a big deal about which way you move your decimals. Okay, we're moving it to the left, which means we're making this number smaller. So it means times 10 to the third. Good. So you make 10 bigger. Okay, if you make your number smaller, you make 10 bigger. If you make your number bigger, you make 10 smaller. All right, so you divide the two numbers. 2.3958 divided by 1.98 gives you what? 1.21. Okay, so one like this, there's not a lot of work to show. Okay, because what are you going to do with these exponents right here? Subtract them. You're dividing. Come on now. You know this. You're subtracting them. Okay, so 3 minus 8 gives you negative 5. So times 10 to negative fifth. Okay, so one like this, there's not a lot of work to show. Okay, I really think you guys can do that in your calculator. I assume you can do 3 minus 5 in your head. Okay, now ones like last one, where you had to move the decimal a second time, show me that step so that way you don't mess it up in your head. Okay, for your benefit, not really for mine. Okay, everybody good? People, that's pretty much it. Your homework is going to be 417, 1 through 17 odd. This is due on Friday. All right, since I don't see you guys on Thursday and we have a quiz tomorrow.
When do you want me to